Okay, so we begin with Gauss's law, which is the integral of the electric field over a closed surface is equal to the charge inside divided by some constant. And let's recall that in your advanced calculus class, you derived that the integral of a vector field over a closed surface is equivalent to integrating over the volume that has that closed surface as a boundary. So, for example, if the closed surface were a sphere, as it was in the previous problem, then the volume that we would be integrating over is the interior of the sphere. So this gets replaced by the divergence of the field, of the vector field. So it's the divergence indicated like that, integrated over the volume, which in our specific example would be the volume of a sphere. Let's say we choose the coordinates, so x, y, and z. So then the volume element would be dx, dy, dz. So it would look something like that. And that is equal to, well, it's equal to, we know from Gauss's law that it's equal to the total charge inside divided by epsilon naught. But the total charge inside can be written as an integral over the charge density, rho e, so dx, dy, dz, right? We integrate the density of charge over that volume, and we divide that by epsilon naught, right? We notice that the integrands are the same, right? So we're integrating over the same object, dx, dy, dz, the same volume, and so it must be true that the divergence of the electric field is equal to rho, the charge density, rho e over epsilon naught. And in our specific coordinates, then the divergence looks like, right, it's a vector, because we have a dot product, so it has to be some kind of vector, right? It's kind of an abstract quantity because it involves operators. So it's I hat, j hat, but partials in x and y and z. K hat d by dz looks like that. And of course, the electric field in these coordinates has an x component, right, on the I hat basis, plus there's a y component, j hat, and a z component on the k hat basis. And so the dot product looks like this dot that, so it looks like I hat d by dx, j hat d by dy, plus k hat d by dz, dot ex I hat, ey j hat, plus ez k hat, right? We do the dot product, and so I dotted with I is just 1, and so we get d by dx of ex plus d by dy of ey plus d by dz of ez.